Welcome to the Algebra Do Now 29.2 video key for D block, and here we go. So if you multiply out x plus 3 times x minus 3, first of all, you might notice that's the sum of x and 3 and the difference of x and 3. Well, you're going to get x times x, of course, and then you're going to get x times negative 3, and then you're going to get 3 times x, and you're going to get 3 times negative 3. Okay, got all those pieces. Okay, I'm going to organize that information. So we know that's an x squared. X times negative 3 is going to be minus 3x. 3 times x is going to be plus 3x. And then 3 times negative 3 will be minus 9. Now, we can organize this a little more. Take it one more step, and we end up with negative 3x and 3x, which is just going to be plus 0x. And we don't need the plus 0x. We're really just going to end up with x squared minus 9. And the first thing you might notice is the middle term went poof. Okay, it disappeared. It was eliminated. It was wiped out. It was annihilated. And another thing you might notice is we have a difference of squares. This is just x squared minus 3 squared. Well, isn't that just like the beginning of this and the end of it? So it's x squared and then minus 3 squared. So this is a very important structure in algebra, and it's going to and going on into calculus and beyond. This is going to be really useful to you if you pay attention to it. So if you have a plus b times what we call its conjugate, a minus b, a plus b and a minus b are called conjugates, and that is an important structure. If you multiply two conjugates, you're going to get a difference of squares. So, and the reason for this is you'll have an a squared. The reason for this is you're going to eliminate the middle term. You're going to have that, it's going to get canceled out. So we'll have an a times a, and then we'll have a negative ab, and we'll have a plus ab, and then we'll have a minus b squared, because that's just a minus b times b. I'll just do it like this. I'll keep that consistent in my process. And then I will clean that up. That's going to be, of course, b squared. And ab and negative ab are just going to be nothing. And then a times a is going to be a squared. So we have the beginning of it and the end of it, the first term and the last term, both squared, and it's a difference of them. Okay, so this is known as a difference of squares. It's very, very important structure. Now, if you noticed all of that, you might be able to do this next one really fast. Remember, it's a sum times a difference of the same stuff. And when you work that out, you're going to end up with the first term squared minus the second term squared. So you should end up with x squared minus 10 squared, which is just going to be x squared minus 100. But let's prove that for ourselves. Okay, we're going to have x times x, and then we're going to have x times negative 10, x times negative 10, and then we're going to have 10 times x, and then we're going to have 10 times negative 10. And we can put all that stuff together. We'll have x squared. We're going to have minus 10x. Then we'll have plus 10x. And then we'll have 10 times negative 10 will be a negative 100, so minus 100. And then the 10x and the negative 10x will cancel each other out, making a 0x. We get a 0x in the middle, and then we can finally end up with just x squared minus 100, which is, of course, the same as x squared minus 10 squared. It is a difference of squares. Now the next one is a perfect square. We're squaring x plus 1, and then we're squaring x minus 1. X plus 1 times x plus 1. So let's work it all out. It's going to be x times x, which would be x squared. Then I'm going to have x times 1, so that'll be a plus 1x. I'm going to have another x times 1, so another 1x. And then 1 times 1 is just 1. Oops. Okay, and now I can put this together. Now I could just say 1x plus 1x, but I want to illustrate something here. That's 2 times 1x, because it's two 1x's. And one of our tools with addition is repeated. We can turn addition into multiplication. This is a very simple one, but then we go ahead and simplify. That's x squared plus 2x plus 1. This is a perfect square, okay? And something you might have noticed is you got the same, you basically had double the inside and the outside products were the same thing. Inside and outside products were the same. Okay, and now one more thing to notice. Because it's a perfect square, we can build a generalized structure around this. So A plus B squared is going to become, of course, that's the same as A plus B times A plus B. So we'll get an A squared, A times A. And then we'll get an AB plus another AB, and then plus a B squared. And then the AB and the AB, we can combine, so you can see it vertically on top of each other. We can take those two ABs, and it's 2AB. And that is, in fact, a structure that will be handy to you with perfect squares. Now let's see if we can apply this structure for the next one. So what I'm going to be doing is I'm going to relate to, so this is a perfect square. I'm going to relate to x as the A and negative 1 as the B. So we can simplify this just like this. I'm going to replace things as they are in the structure. So A will be x. So I'll put it in x wherever A shows up. And B is going to be negative 1. So wherever B shows up, I'm going to put in a negative 1. Okay. And let's simplify that. Negative 1 squared is just going to be 1. 2x times negative 1 is going to be negative 2x. Like that. Now, that is what the structure leads us to. Let's see if that actually pans out when we multiply it out. If I say x squared, and so x minus 1 times x minus 1, I'll start off with an x times x. Then I'll have an x times negative 1, so an x times negative 1. I'll have a negative 1 times x. And then I'll have a negative 1 times negative 1, because that's negative 1 squared. Spread them out a little bit so the negatives aren't too confusing. Okay. And negative 1 times negative 1 is 1. And that's going to be negative 1x. That's going to be negative 1x. And then x times x is x squared. Since that's a minus, we'll treat that as subtraction. Also a subtraction. This is addition. This is positive, so we'll treat it as addition. And we can combine these. So these are going to end up being, there's 2 of them. So plus 2 times negative 1x. And then one last step, we'll have x squared, and then 2 times negative 1x is negative 2x, and then plus 1. And indeed, we got the same dang thing.